In the last few videos, we already used function notation quite extensively, but in this video, we want to have a little bit of a closer look how exactly this function notation works. So here we see a function represented by a graph, and so we can see that for different inputs, we have different outputs. The first question asks us, what's f of 10? And so we look at input 10, and we want to find the associated output. So we find our input 10 and then go up to the graph to find the associated output. And it's a little bit hard to see, but it's roughly, if this is 10, 1, 2, 3, 4, so 2, 4, 2, 4, 6, 8, 10, this would be 12. It's a little bit more than halfway, so that's about, so this is 12, this is about 11.5. So when the input is 10, the output is about 11.5. Now, what about the other way around? What if I know that the output is 10? So here I have the output is equal to 10. That's an ugly looking word, but the output is equal to 10. What input gives us that output? Well, let's see. So now I'm looking at the output 10 right here, and it looks like there are actually two places where I'm hitting this output, which is okay. One is over here and the other one is over there. So I can estimate those values, and again, each tick mark is about 2. So that's about 7.2. Or the other one, that looks about 18.7. I'm totally estimating here. Now, sometimes I don't want to specify numbers. I just want to ask what's f of a, and a is sitting right here. It's my input right there. Even though I could estimate it. I don't know what it is exactly, but I can still estimate the output. And it looks like f of a is about 6. And then finally, what's f of 10 minus f of 6? Well, I already know that f of 10, go back, is 11.5. F of 6 I haven't found yet, but I could. So let's go up to the graph and see if we can find it. That's about 8.7. So f of 10 minus f of 6 is 11.5 minus 8.7, which turns out to be 2.8. So that's how input and output work if I just have the graph of a function. Let's look at an example in the exercises, just the first one. The following table shows the amount of garbage produced in the US as reported by the EPA. And we have the amounts of garbage right here. In the year 1960, that's our first year, and then 65, 70, 75, 80, 85, and 90. And G is going to be our amount of garbage. That's a variable we are using for the amount of garbage, and we consider that the output, we are looking at G as a function of time. So G is equal to f of t. So our input is time, and our output is millions of tons of garbage. And they're asking us what's f of 60. We've used tables before, and so we can just go up to the table, and our input is 60 and it has output 90. So we get that f of 60 is 90. Now that 90 has units associated with it. So the units of that 90 is millions of tons of garbage. And I can actually write a sentence right here that tells me the meaning of this compact equation f of 60 equals 90. It tells us that in 1960, the US produced 90 million tons of garbage. So we can say in 1960, the US produced 90 million tons of garbage. We can do the same thing for f of 75. F of 75, going to my table, is 130. And that again is million tons of garbage. And I could write a similar sentence. It would be in 1975, the US produced 130 million tons of garbage. They're also asking us to solve f of t equal to 165. And so this 165 right here, that now is an output value. So that is millions tons of garbage. So that is a garbage number. And it's 165. So we have to go to our output row, find 165, and conclude that the associated input is 85. So t equal to 85 is our answer. That is a year. So this is 85 years, which represents the year 1985. So after having solved this, we can also say that in the year 1985, the US produced 165 million tons of garbage. So function notation, again, is a very compact way to talk about the relationship between two variables. And in our case, our two variables are years since 1960, and since 1900, and the garbage that the US produced in those particular years. If you like, you can go through and do the rest of the exercises just to get a little bit more experience using input and output of functions. And the solutions are in the handout that's linked